regression and creating new variables that are uncorrelated. Can you hear me? Let me see in the chat. Can you hear me, participants? Okay. Thank you. And in case you have a question, utilize the Q&A for a question, and we shall use the chat for the questions that I ask. Thank you very much. Okay, so let's continue. So multivariate techniques are applicable when more than one variable is measured on an experimental unit. And in most cases, such variables are correlated. For example, if we try to model a baby's growth and we have two new diet produced, we would look at their head size, we look at the length, we look at the width of the body, we look at the eye color, we look at so many variables, but we'll find that all those variables are correlated, and we cannot actually run a regression of growth as a function of the variables that we've mentioned. And because of that, multivariate was created. Univariate analysis, as I've just mentioned, is not helpful because we know that under most of the regression analysis, under analysis of variance, we assume the data is normally distributed. We assume the unexplained variations are not correlated. And in case you run correlated data, then the unexplained variations are going to be correlated. That's why we resort to multivariate data analysis. Today, we'll be looking at principal component. I know that my colleagues talked about it, and I'm just going to briefly talk about what principal component is. It is a multivariate technique that creates new variables that are uncorrelated from very many correlated variables. So assuming we have P variables, for example, X1, X2, up to XP, and they are measured on n experimental units, where the experimental units will go into the rows, and then X1 to XP will be the variables. We find that we can organize our data in a matrix called X, where we have the components n times P. And that matrix can be represented as you see here. We have X1 on experimental unit 1, dash, dash, until X1 P. So this is how multivariate data is presented. And if you're going to do multivariate as a statistician, you have to learn matrices. But in this case, we are not going to do that. We are just going to go through the theory and do the practicals. So now using multivariate, using principal component, which is abbreviated as PCA, we can compute several P times P matrices using either sums of squares or sum of cross product of X. So we can also use the corrected sums of squares for the X values, where we have in the corrected sums of squares, we subtract the observed values under each variable minus the mean of each variable, and then I get a cross product and calculate the P and P variables. We can also compute the correlation matrix, which we can use to compute the new variables. So PCA is done on these matrices, and it's therefore important to select which type you're going to use. In this case, we are going to use the correlation matrix. I'll tell you why we select the correlation matrix. So you can either use the corrected sums of squares, you can use the sums of squares, but in this case, we will use the correlation matrix. And the operation, after I've chosen one of the matrices, produces what we call latent roots or eigenvalues. It produces eigenvectors, and each latent root corresponds to an eigenvalue, an eigenvector. Yesterday, they talked about this. We also see what eigenvalues and eigenvectors are. So with P highly correlated variables, we can produce P new variables that are not correlated, but they're a function of the original data that you collected. So let U1, U2 be the new uncorrelated variables. So for us to express them as a function of the original variables, we'll see that mu1 or U1 will be equal to a slope and x1 plus a slope, x2 until xp. So we can create several new variables depending on the number of variables you have in the original data. So the number of principal component is equal to the number of variables in your data set. If you have 5 variables, then you are able to create 5 new principal components. So when we create the principal components who have P variables that are uncorrelated, during the process, we rotate the original axes such that the first principal component has maximum variation, explains most of the variability in the data. The second one, which is uncorrelated to the first one, explains the remaining variation. The third, which is uncorrelated to the first and second, explains the remaining variation, and so on until you get number of principal component equal to the number of variables in your data set. So during principal component analysis, we transform the original variables to new uncorrelated components that account variability in the data, and they are arranged in descending order. So if U1 accounts for maximum variation, U2 accounts for second maximum variation, it is independent. I mean, U1 is independent of U2, and so on. So what's the use of PCA? The uses of PCA or principal component are discovering dimensionality of the data. In dimensionality, we are talking about reducing the data variables from the correlated values to uncorrelated value. Data screening, where we can find out whether we have made mistakes or we have outliers. We can also check whether we have clusters and then find abnormalities using the scatter plot. Okay. So after you've created the principal components, the new uncorrelated variables, you can now conduct multiple regression with those new variables that you've collected or you've created using principal component. You can plot the first principal component, and it helps you to identify the clusters associated with the data. You can partition the G times E in absence of replication. So those are the uses of PCA. Also, PCA can be used in other multivariate data analysis like discriminant analysis, factor analysis, etc. So in R, several functions from different packages are available for you to conduct principal component. We have PRComp or PRINComp built in R stats package. So that one exists. Then we have principal component built under factor minor R package or factor X extra. And all these ones, you can choose whichever you feel like, but whatever you choose, you'll be able to extract the principal component. You'll be able to visualize the principal components. Okay. So we'll choose one of these, most likely we are going to use factor extra R package. So in R, before we use, if we choose to use correlation, we first of all standardize our data. Why do we standardize? Because you might have measured, for example, if you measure length, length is measured in meters. If we measure the girth, we will measure it in centimeters. If we measure the eye size, we might measure it in inches. So you find that the variables have different scale. So you cannot use variables with different scale to obtain principal components. So we standardize those variables to make sure they are comparable. And when we create the principal components, we are creating principal components with data of the same scale. So we use the scale function to standardize the variables. So after you've standardized the variable, you can carry out principal component analysis using pre-comp, which is a function in R. And this gives us the standard deviation for each component, the proportion of variation explained by each component, the standard deviation for each component. We can also decide on how many principal components we are going to retain, either using the Scree plot, as we shall see later, or looking at the amount of variability explained by each principal component. How do we determine the number of principal components to keep? As I've just mentioned, we can use the Scree plot to set the total number of variation accounted for, or you can use the eigenvalue rule, whereby we choose all those principal components with an eigenvalue greater than 1. So under package factor extra, there are certain functions that we are going to be using. We have one of the functions used for visualization of eigenvalues. Then if we want to draw graphs, we have a function for drawing graphs. We also have, if we want to get the eigenvalues, we use also a function, as you see in the notes. So function 1, 2 is used for visualizing the principal component, and then 3 extracting data from the principal component. And the data that we extract, we can see the coordinate, we can see the squared cosine, we can see the contribution of each variable to the created principal components. So the principal components, the first principal component that you choose consists of the maximum variation or the largest variation. And normally we place that on the x-axis. And then we have principal component number 2, which has the second largest variation. That is the amount of variability explained in the original data. And PCA1 and PCA2 are orthogonal, meaning they are independent of each other. Now, the amount of variation or the amount of variance retained by each principal component is measured by the eigenvalue. So what's the difference of using covariance matrix and correlation matrix under principal component? You can use either of the two. Under covariance matrix, we do not standardize the data before we run the principal component analysis. So when you choose to use the covariance matrix, then the principal components are obtained from the raw data without any standardization. And directly you get the eigenvector and eigenvalues. So these ones are useful if your variables are similar in scale. And in case they are not similar, then you may not get good interpretation of your results of the PCA. Then when we use correlation matrix, the first thing we do is to standardize each variable we standardize them in such a way that each variable, new variable, has a mean of 0 and a standard deviation of 1. And in so doing, we make them comparable. After that, we compute the eigenvector and eigenvalues of the correlation matrix. When we use correlation, we want to identify relationships between variables. While in the covariance matrix, we want to look at which variable has the highest variance or amount of variability explained only. We can't establish relationship between variables. So covariance indicates the direction of the linear relationship between variables. Covariance is an indicator of the extent to which two variables are dependent on each other. A higher number denotes a higher dependence under covariance. Correlation measures both strength and direction of the linear relationship between two variables. Correlation values are standardized, while covariance values are not standardized. So once you use correlation, we are able to know whether two variables are strongly related or not. The covariance lies between -infinity to +infinity, while correlation lies between -1 to +1. So those are the differences between covariance and correlation. Okay, in the chat, let me see in the chat if you have any question. Okay, you seem to be okay. Let me see in the Q&A. Okay, the materials are in the Google link. It has been posted. My colleague, Dr. Helen, is going to post again the Google link. It has the file, the PowerPoint file. It has a data set. Instead of getting the data set from from R, I downloaded it and saved it as a CVS. So we are going to use that. So make sure you put it in the folder where you're keeping your PowerPoints. And also the R script is part of it. Okay. Okay, so it appears like people are comfortable with the principal component. If that is the case, let me see in the chat. Are you comfortable with the theory of principal component? We are going into R. We are going into practicals. Okay, in the chat. Are you okay? Can we go ahead to the practicals? If you don't say yes or no, I will assume it's a yes. Okay, thank you. Okay, so now I'm going to stop sharing this, and then I'm going to share the R script. So let's turn to R and do practicals. We turn to R and do practicals. So I'll give you 2 minutes to turn to R so that we can do practicals. Somebody is saying the file is not downloading. Maybe you need to unzip before you can download the file. Okay, so in the chat, can we start practicals? Can I see your response in the chat? Can we start? Some people are saying no. Okay, I will give you 1 extra minute, please. Make sure installing packages, perfect. Now, if you have downloaded the script and you see that you do not have those packages, you can install them. But if you have the packages, don't install second time. Okay. So I can see that the file is zipped. So unzip. First unzip that file before you can access. Okay, I request my colleague, Helen, please in the chat, can you paste the script and also the data set so that people can access? I think some people do not have the unzip file, or they do not have that program on their computer. My system cannot unzip, okay? So my colleague, Helen, will post the files in the chat. Make sure you capture them and then save them on your folder. Helen says she has uploaded a folder that is unzipped. Please send it in the chat and Q&A, Helen. The one which is unzipped? No, they want the unzipped one. Can you please send the Google Drive with unzipped file so that people can access? Okay, so can we continue? File cannot open. I can't see it in the chat here. It's not in the chat. Is it okay now? Have you received the file? Okay, thank you. So we are going to start. I do not want to start and then we go backwards and then start and, you know. Okay. Dr. Helen has sent the R script in the chat. Make sure you pick it. Okay. Okay. The R script and Irish has been sent in the chat. Okay, pick them and save them in a folder that you can access on your computer. Okay, so I think we can start. So let's pay attention to the script. So the first thing, look through these packages. If you think you don't have any of them, then install. If you have them already, do not install. For example, you must be having factor extra, factor minor, R, galley, Biplot, even this one. I think you only do not have Gigi Biplot. So make sure that you do not install second time. The only thing we can do now is to run line 13 onwards, that is, we load the packages. So after installing, let us load the packages. So just highlight and load the packages. Okay. So for principal component, we need these packages highlighted as install. And you can use one of them, not all of them at a go. So let me see in the chat. Has everybody loaded the packages? Okay. Okay, thank you. So let's continue. So since we download the data, we are going to set working directory. So you go to session, set working directorate, choose working directory. That's where I am. Session from the RStudio menu, set working directorate, choose working directorate. Okay. So click, choose working directorate. And the directorate that has come is what I am using. So you click on the name on the folder that where you've stored Irish data and click open. Okay. So in the console, you see that there has been a command written, set working directorate, in brackets, the root showing where the folder is. Okay, in the chat, has everybody set their working directorate? Is everybody okay? In the chat, have you set working directorate? Okay. Thank you. Okay. So we are going to line 41. We are going to read our data into R using the read.csv. So you just run those two lines and run, and you see the data. Oh, okay. Is that visible? People are complaining about the size. Is it visible? Is it visible? Okay. Okay, thank you. Okay, so line 41 and 42 shows us how to import data into R. Okay. And once you run line 42, you will see the data set in the console. So if you look down here in the console, you'll be able to see the data set, which consists of 5 variables and 150 values. Okay. So the data we have consists of the sepal length, sepal width, petal length, petal width, and the species. Okay. So I'm assuming that you all have the data. So we are going to, the next part is normally what you do when you receive a data set. We normally do some descriptive statistics, which can either be means or graphical displays. You can either do numerical display or graphical display. So in this case, I've chosen a few things that you did with Dr. Helen and presented them here. So the first thing you do, you can choose one of the variable and draw a histogram to check whether the data is normally distributed or not. So if you look at the plot window, you will see a histogram. And I think you can see that that histogram is skewed to the right. Is that what you observe? Let's see in the chat. Oh, you are too fast. Okay. I'm going to reduce. I thought, okay, okay, I'm going back to the chat. Do you all have the data set? Do you all have the data set? Say yes. Okay, if you have the data set, If you can't set the working directorate, you can go and type data in bracket iris. Then you run. It's going to bring the same data. So the only thing you'll be left with is to give it an object name that is going to help you run the rest of the analysis. Okay. So I'm still installing. Okay. Or if you get a warning which says package Gigi Biplot was built for version 4.41, it means that you need to update your R. So you'll go online and download R, but in the meantime, pay attention as it's being downloaded. Then later you can update your R once you've downloaded the file. Okay. Your histogram looks normal. No, it's not normal. You look at this tail here between 7 and 8. And also between 4 and 3, we have another tail there. A bit skewed, and the longer tail is on to the right. That's where we are saying that the data is skewed to the right. Okay. So are we good to go? Can we go to the second bit? Kindly share the link. The link has been shared, but it will be shared again. Okay. So the histogram is picked. Yes, it has a peak, but not really picked. Picked means that it has a pointed shape, but in this case, it's a bit flat. How to update R? First of all, do not pay attention to updating R. Leave R alone. Just make sure you are in the script and paying attention. Unexpected error. Pardon? Okay. Okay. Okay, Dr. Nyararo, can you promote half-tone? So I'm going to stop sharing so that we sort this problem out. Maybe other people also have it. Can you promote anybody who is taking care of the ICT, promote half-tone? Or anybody with an error, put up your hand so that you can be promoted. Should I stop sharing? Is the person being promoted? Dr. Rinyararo, can you please promote half-tone? Promote half-tone. You can get R, just go online and type in okay. Hafton, you've been promoted. Please share your error so that can be corrected. Maybe it can help all the others. Please make sure you share your script, your R script. If Hafton is not ready, Joseph, can you please share your script? Somebody with a long name, BIRU, can you share? Okay. Pardon? Please share. You've been given the rights to share.
Yes. Is Kato with you, Professor?
Pardon?
Is Kato there?
Yes.
Okay.
Yes. Thank you. Please share. If you've been given a right, share. One of you, Melissa or Bill, please share. Okay, since you're not sharing, I'm going to share my script and we go on.
No, they're not promoted, been promoted. Who do I want to share?
There was Hafton. Then there is Melissa, a Queen.
Maybe they type their names in the chat so that I can see their names, because I'm trying to search and I don't see them.
The names are in the chat. I can see some names in the chat. Have they been promoted, those ones?
No, I've not yet promoted anyone.
Okay.
I want to look at Melissa. I'm not seeing Melissa. Melissa Shirley.
Melissa Shirley, can you share? Melissa Shirley, can you share your R script?
Do you have another name?
There is Hafton.
Upton.
Yes.
Melissa is declined.
Okay. If Hafton is not available, there's also Joseph.
Joseph who?
Joseph or B.
Something of the best. Okay, yeah. I'm promoting that one.
Joseph, you're being promoted. If you're here, please share your script so that we can see the error. Then there's Patricia Dumbe.
Joseph is joining.
Okay, thank you.
Joseph, you can go ahead.
Yes. Good afternoon, Prof.
Good
Please,
afternoon.
So the issue I'm having is that I was following the webinar with my phone, not with my
yes.
laptop, because my laptop, crashed. Or the hard disk got crashed. So I have to reinstall the ML Studio, and that's why I'm busy looking for a compatible one first before I can start all over with what I want to do. That's
Oh,
that's why,
okay, no problem. Let's have another person share.
Patricia has declined.
Choose any. Patricia is still there among those who have put up the hand.
She has declined. I just promoted her.
Okay.
She
And
said that I'm updating the R studio.
okay,
So maybe
Queen.
you can move on now.
Okay. There's also Mohammed.
Mohammed who?
Hassis.
I'm seeing Mohammed Ibrahim.
If Mohammed doesn't share, then I'll go ahead.
Yeah, please go ahead.
Okay. Let me share the screen again. Okay, so people are saying that the histogram was normal. Let me share this, stop sharing, and share the histogram. This is the histogram I've gotten from the data. Is it visible? Is it visible to everybody? Is the histogram visible? Yes, okay. So you can see that this histogram is not normally distributed. It has a tail. See this tail here, which is the tail to the right, and it doesn't have a definite peak. Its peak tends to be a little bit flat. So not normally distributed. Okay. So from there, these are just preliminary analysis you can do with your data. Let's go ahead and see what else you can do. We are just doing a recap. Remember, you've already done this. We can create a scatter plot, which you've already done. So we are going to line 52 and run line 52 to 57. So we run that and we get a scatter diagram. So let me zoom in the scatter diagram. So this is the scatter diagram. So what do we see in this diagram? In the chart, is there a relationship between sepal length and sepal width? Okay. Do you see any relationship? Not much, yes. There is a weak relationship between sepal length and sepal width. So that is very good in the chart. The answers are correct. A weak relationship between sepal length and sepal width. If we had a strong relationship, the points would be close to each other. Okay. Okay. So we can close this and then go to the script. After creating we go to line 70, and here we are just doing the same thing, but in this case, we want for all the data set. So we create a class, we create colors for the 3 species in the data set using line 70. So you just run line 70 to just assign colors to the species. Even if you see none, it's okay. Then we run line 72, which is the panel Pearson. So it's going to create graphs, including the Pearson correlation. So let's also run line 78. So you run line 72 to 78, and that gives us a plot. So let me share the plot. So you run line 70. Make sure the first thing you do is to run make sure you run line 70, then you run line 72 to 78 for us to get the graphs. Okay. So I'm going to rerun this. So if we run and then run, we get the data, and then I zoom in. I just want us to look at the relationship. My zoom plot must be somewhere. Okay. Anyway, let's look at this section of the, make it wider in the plot section as I look for the zoom plot. It has disappeared somewhere. Let's use this and explain. Okay, so let's look at the plot window in my screen. Although it's not zoomed, I hope you can visibly see that sepal length and sepal width are correlated, though not highly correlated, but sepal length and petal length are highly correlated. You can see the points are together. The same applies to sepal length and petal width. You can see the points are highly correlated, forming a straight line almost. So we can see above here in this, we see the correlation values between the data values. Okay, so I think let's go to the script. We are going to see that more and more. So the next thing is we can use the Gigi pairs to construct the scatter plots, the histograms at the same time as they are. So if we run line 83, so line 83 produces the scatter diagrams, it produces the histograms, and it also produces the box plots as well. So you can look at it in your screen. Let me go to the chart. Does everybody have the same plot like mine? Says error in Gigi pairs. Make sure that you install all those first. Please reshare. I didn't see that one, Tren. Reshare today's Google Docs. Okay, my colleagues will share. Okay, you have a minor error. Mine is error. Post this error in the Q&A. You'll get a response. Please upload today's work. Okay. Okay. So if you have the same chart, look at your chart and see that the chart we produced earlier on is almost similar to what we have. But in this case, we have it colored. You can see there are species in red, species in blue, and then species in green. Okay. Dr. Helen? Okay. I'm looking for my zoom button and the zoom seemed to have hidden somewhere. But as soon as I see it, would be very nice for us to see. So if we look at sepal length, that is the first line, you can see the box plots show that the species in red, in blue, which is Virginica, has the highest sepal length. And the species in green, which is Vascola, has the second highest sepal length. And then while Setosi has the lowest. If we go to sepal width, although Setosi has the lowest sepal length, it has a wider flower. You can see the sepal width is higher compared to the two box plots. That's how we interpret the middle line represents the median. So that is part of the descriptive stat we can do. And now I want us to produce the correlation matrix, which is now going to show us which variables are correlated with which other ones, and should we go ahead and run multivariate analysis. So let's run line 86 to 87. 86 produces a correlation matrix. You can see there is a -5. Dr. Helen talked about it, means that we've subtracted the fifth variable, which is categorical. So if we run in your console window, if you go to the console window, you will see that we have correlations. Sepal length and sepal width is very weak and negative. Sepal length and petal is very strong, 0.87, very strong and positive. Sepal width and petal length, we've already said is weak. And then petal length and sepal width, we see that it is minus, it is weak also, less than 0.5. So we see that petal length and petal width are highly correlated, almost a perfect correlation of 0.96. So if we wanted to model the growth characteristics of this flower, we may not be able to use regressions, multiple regression, because of these correlations that exist in the data. So now let's go ahead and prepare our data for PCA. So line 90, we prepare the data for principal component analysis. So the first part of line 90 is the object name is PCA underscore result. Assign PCA, which is the command. Irish is the data set. Subtract the last variable, which is categorical, because PCA calculates the principal components for only numerical values. Graph equals false. Don't construct a graph. So let's run line 90. And then you run PCA results. So it's in PCA results, it's going to tell you the names of the variables that you find in PCA results. So before you see the real numerical values, you have to use summary, PCA underscore results, to see the real numerical values. So run line 90 and it will show you the values. So Let's go to the beginning. So what I'm going to do is I'm going to clean the console using the brush, this little broom, and rerun summary, run line 92, so that we can see clearly what is in there. Okay, so in the chart, okay, if you get an error that the function does not exist, it means you have not installed the packages. You know, at the beginning here, we had some packages installed. So make sure you install line 3 to line 9. You see, there is factor extra. That's where the PC is coming from. So make sure it is installed. Factor minor, galley, core, plot, ellipse, and then grid extra and gigi Biplot. Gigi Biplot holds the gigi pairs. So make sure you have gigi pairs installed, okay? All these packages should be installed before we can do. So make sure you install all of them so that you don't ask which one does that, which one does this. At the end of the lecture, you can actually go in Google and say, what does gigi Biplot do? Okay? Please, the script in dev 4 is empty. Would you check it? Helen, please post the Google link with the unzipped file. I'm installing, but gigi does not function, gigi pairs. Please install all these, okay? Gigi pair works together with the gigi plot 2, okay? So gigi pairs works together with the gigi plot 2. So make sure even these ones, you see in my loading packages, I was assuming that you've already installed gigi plot 2, gigi view, pub, a library. You've already installed read R, read Excel. Dplyr is also necessary. So if you go to line 13 up to line 20, line 30, if you run them and one of them says object not found, that means that you have not installed that package. -5 means we've removed the fifth column, which has species names. Okay. Okay. Okay, in 5 minutes, is everybody comfortable? Can we go ahead with the interpretation? Because I want to go and interpret this output. Biplot 2 is misspelled. Make sure I spell the names of the package correctly. It's Biplot 2. Make sure it is well spelled. Okay. Okay. I am going to go back to the beginning of this script. Reason, if you didn't install these packages, we are going to be going back and forth. So let us go to the beginning. Okay. At the beginning, in case you find that you have an error when you load a package, just pick the package name and write install.packages in bracket, the name of the package. Okay. So at the beginning here, I said, let's install the packages that are required. So there's factor extra, and there's also factor minor, galley, coplot, and ellipse. Now, also there is also grid extra and gigi Biplot. So those ones are required for multivariate analysis. But we've already covered some of the R packages down here, which I thought you already have, like tidyverse. Now, if you don't have tidyverse, create another line of install and put in tidyverse. If learner R is not working, create another line of install and put in brackets, inverted commas, learner R. If dplyr is not working, so when you run line 13 to line 30 and you get an error, it means that one of the packages is not installed. Okay. Okay, so I'm giving you 5 minutes. Let us sort ourselves out. My colleague Helen, please share the link. Some people haven't gotten the link. I think they've just joined. Okay. So 5 minutes, you have 4 minutes to sort yourself out. 4 minutes. And once we go to principal component analysis, you should now not have those problems of this package is not running, this function is not found. Okay. Okay. In the chat, is now everybody comfortable? Have you run the analysis of principal component and gotten the output in my console? Let's see. Somebody is saying no. Okay. So if you say no and you have a question, put the question in the Q&A. My colleagues will answer the question. So if you install the packages, please try to run line 90 to 92. Operation functions are not working. Which ones? Please be specific. Now, if it says restart R, say yes, it is not going to restart so that you can go on. You can download the packages. You don't actually need a website to download the packages. Just click install. Just write install.packages in bracket, the name of the package. And if you're connected online, it's going to connect to Scree project where those packages are stored. If you're getting a problem like warning message, package grid extra was built for version 4.41, it means you've not updated your R version. Okay, so for now, ignore that. And when you reach at that point, we can now struggle to see how you can update R. Make sure factor extra is installed. Justin, make sure factor extra, Justin Nalvega, make sure factor extra is installed and you've loaded it. So after installing, click library in bracket factor extra and run. PCA is under that. Okay. Okay. So are we good to go? Can I go to interpret the results? I want to go to interpret results when everybody Okay. So if you're okay, then we are going to go to the results. Make sure you have results starting with eigenvalues. You remember in theory, we said that the variance explained by each principal component is stored in eigenvalues. Now, under package factor extra, the principal component are named DIM, DIM. So DIM is principal component number 1. DIM2 is principal component number 2. DIM3 is principal component number 3. DIM4 is principal component number 4. So here under eigenvalues, you see the variance explained. You see percent of variation explained. The first principal component has explained 72.962% of the variation in the data set. The second one has explained 22.851. The third one, 3.669. The fourth, 0.51. So if we are to select how many of the principal components we need to use in the further analysis, if we add 72.96 and 22.85, we already above 70. So we can go ahead and use principal component number 1 and number 2. But we are going to look at how to select the principal components. The last part is cumulative percent of variation. So we see that the first principal component has 72.96. If we add 22 to 72.96, we get 95.81. If we add 3 to that, so the last row indicates the cumulative amount of variation explained. But the cumulative is just telling you that when you got principal component number 2, you've already explained 95.8% of the variation in the data. So you don't need actually to look at principal component number 3 and number 4. Okay. So when you scroll down, you see variables where there is sepal length, sepal point length, sepal width, petal length, and petal width. So from there, we also see DIM1, which is principal component 1. So this particular table is telling us which particular variable is responsible for the 72.9%, which one contributes to creating principal component number 1. So we see that if we look at the values, we see that sepal length has 0.89, petal length has 0.992, petal width has 0.965. So in this case, principal component number 1, these 3 variables contribute positively to principal component number 1. And when we got principal component number 2, it is sepal width. If you see sepal width, let me highlight it. It is 0.88. It's contributing 0.88 of the variability in DIM2, which is the principal component number 2. So from there, we know that this DIM2 is summarized by the sepal width. Okay, so let's go ahead and see what other principal component does. So if you want to see only 6 results of your principal component, you can use the head PC underscore result, comma 6. So you see only 6 first values. But I want us to go we go to get eigenvalues and see. So we got line 99 and line 100. So we want to get eigenvalues from PC results. So in order to get the as eigenvalues, let's name the eigenvalues eigen.val equals to get underscore eigenvalue in brackets the file name, which is PCA underscore results. So if we run line 99 and then run the object name, it's going to give us a summary of the eigenvalues in each principal component. And we said in our theory that if a principal component consists of an eigenvalue greater than 1, then we can select it and include it in our analysis. So we see that DIME1 consists of eigenvalue of 2.9. DIME2 has 0.9. And it also has the variance explained. You see variance dot percentage. That is the amount of variability explained. So the principal components 1 and 2 are that, or up to 4 are the new variables that have been created from your original data, which is Irish data. And then we now know that principal component number 1 and 2 are the ones explaining over 90% of the variation in the data, and we will use them in the further analysis. The next line, which is get a list of variables in PCA. So we want to see what is in PCA underscore results. So PCA underscore results, if we run line 103 and then run var, it consists of the variables that are embedded in PCA result, PCA underscore results, which are the coordinates for the variable, correlations between variables, cosine, squared, and a contribution of each variable towards each principal component. Now, if you want to know what the coordinates have, then you can run head var $ code to give you the coordinates within PCA result. So let's run line 108. So if you run line 108, you see the coordinates within the principal PCA result. If you go to head, this is just viewing what you have calculated. It also gives you the cosine squared. If we go to line 114, it gives you the contribution for each variable towards the principal component. So from the contribution, we can know that principal component number 1 is summarized by the sepal length, petal length, and the petal width, while principal component number 2 is mostly summarized by the sepal width. Okay. We want to put all that information in a data frame so that we can run other analysis using that data frame. So I'm just going to clear my console using the broom. In the right top corner, there's console clear. If you click on it, that little broom clears the console. Okay. So in the RStudio, line 116 to line 118 gives us the results of the data frame. So I'm reminding R that my object PCA and underscore results is equal to function probe comp. The data is iris, subtract the 5th column, center and scale. So let's run up to 118 and see what happens. So we get the data set in that data frame. Okay. And that one consists of all the PCAs, PCA1, PCA2, PCA3, PCA4. So that in future, we can use that data frame to plot our PCA, okay? Okay, in the chart, does everybody understand what PCA, principal component analysis, does? In the chart, I can see 2 no's. Yes. Saying in the chat, tell me whether you can understand what principal component does from the analysis. You stopped running from line 98. Okay. Okay, let's go back. We are going to go back once and then we will not go back again. Let's go. Somebody said he stopped running at line 98. Okay. Alpha, thank you very much. It gives dimensions and explains the contribution of variation to the total variation. Okay. Some people have understood. Now, for the sake of those who have not understood, okay. I believe it. The ICT person is recording. Interpreting results. Okay, so we say that we prepare our data for PCA. Principal component, what does it do? We said it reduces the correlation in the original data set by creating new variables that are uncorrelated. But those new variables, called principal components, consist of the data from the original data set. So that when you run further analysis, you're able actually to relate the principal component and your original variables. So why don't we use other methods like multiple regression? We know that under multiple regression, there is an assumption which says that the independent variables should not be correlated for the analysis to be valid. So in this case, we've already seen from our output that these variables are highly correlated, correlation ranging from 0.4 to 0.99. So since the variables are highly correlated, we cannot run a multiple regression because we are going to be faced with a problem of multicollinearity. Mult means many correlations among variables. So that's why we decide to use principal component. What it does, it gets the data, creates new variables called principal component, PCA1, PCA2, PCA3, PCA4, or depending on what you've used for analysis, you can see DIME1, DIME2, DIME3, DIME4. Those are principal components. They are a function of the variables in the data set, okay? So line 90 helps us prepare our data called iris, and the results are stored in PCA underscore results. So PCA underscore result consists of the eigenvalues. I said eigenvalues summarize the amount of variability explained by each principal component. And we also say that if we want to select how many principal components to use in further analysis, we look at those principal components whose eigenvalues are greater than 1. Okay. We also said in the theory that we can also use a Scree plot, which we are going to construct. So let us go to the summary. I am going to clear my console again. So I'm running line 90. So run line 90 to 91. It gives you what is consisted in PCA underscore results. For us to see the numerical values, we have to use summary in bracket PCA underscore results. So let's run line 92. Then it gives you all this. So it gives you the eigenvalues with dime 1, dime 2, which are the principal components. Under the eigenvalue, you have the variance of each principal component, that is row 1. Row 2 has the percentage of variability explained in the data. You remember that principal component number 1 is a function of sepal length, sepal width, petal length, and petal width. And it's sort of like a regression. So the amount of variability explained by principal component number 1 is 72.96. Meanwhile, dime 2, which is principal component number 2, explains 22.85% of the variation. Of the remaining variation out of 100, if we remove 72.96, we remain with the around 28 point something. So out of 28, 22 has been explained by principal component number 2. And then the rest is explained by principal component number 3 and number 4. Then cumulative percentage is you just keep adding the amount of variability explained by one principal component onto the other. For example, 72.96 2 plus 22.85, you get 95.813. So you keep adding like that until we go up to 100. Okay. Okay, so from there, so in the chart, is that bit okay? Okay, so let's go ahead and interpret the last part. The last part is showing the variables corresponding to each principal component, which is dime 1, dime 2. You can see on the left, we have the variables sepal length, sepal width, petal length, and petal width. So now it is telling us which variables are responsible for creating principal component number 1. So for principal component number 1, it is the sepal length, it is the petal length, and the petal width. Sepal width is negative and it's even small. That's why it is not really contributing a lot to creating principal component number 1. It is the others that are contributing to creating principal component number 1. Now, principal component number 2 is being created by, it is summarized by the sepal width. Okay. So the rest of the principal component, we can see dime 3 is summarized by petal width, because the rest, petal width is actually summarized by petal width and sepal length, where sepal length is negative. Okay. So let's go. I'm going to go to the next part. I've run to line 116. That's where we need to start and go on and explain again. I'm also going to clear my window. And I want to briefly stop sharing because I want to pick the Zoom part, which is we will use for the plots. So give me 2 minutes to stop sharing. And okay, I've gotten the function that I wanted has disappeared. So we are good to go. So let's turn to line 116 up to line 118. Is the screen clear? Can you see the R script? Can you see the R script? Okay, thank you. Okay. So starting from line 116, the rest you can run. We were just saying that in the var matrix, there are several things that you can retrieve, the contribution, the eigenvalues. But let's start here because of time, so that tomorrow you can have time to do class analysis. Okay, so what we are doing here is create a data frame that consists of our PCA results, so that in future we can use a data frame. So we will run line 116, where we have an object still, which is PCA underscore result, assigned to PR.com. Data is Irish, -5. You center and scale. So if we run that, and also run, so in the second part, we are saying PCA underscore data is equal to data frame from PCA results, $X, species is Irish, $species. Okay, so now we brought our species back. And then we can print the data. So that is just printing the data set. And I believe everybody has the data set. And the data set consists of 4 principal components. Okay. So next we are going to draw plots. And these plots, that's why I was looking for the zoom function. These plots will be showing in the plot section, and some of them will need to zoom in. So we can use ggplot to plot the data set, which was the data frame we formed, PCA under data. And we want to plot PCA1 versus PCA2. So let's run line 121 to line 123. So just place your cursor and then run that. So you will be able to see a scatter plot of the principal components. But at the same time, you're able to know which points belong to which type of flower. So I'm going to zoom in here. Stop sharing and share the plot. Okay. So I hope this is visible. Can you all see the graph? It's a plot of principal component 2 and principal component 1. And you can see that Vascola and Virginia are closely related. They share something in common, while Setosa is separated from the two. And it is mostly being explained by the negative values of PC1 and the negative values of PC2. That is Setosa, the group Setosa. Meanwhile, Vaginica, you can see it is tending to the positive side of PC1, and also Vescola is also tending to the positive side of PC1. So being summarized by the positive values in PC1, while PC2 is being summarized by the values, the negative values of PC2. So this is just a scatter plot of the principal component you've created from the principal component analysis. Is there any question in the chat? How can somebody add percentages? Yeah, I think we will do that later. We are going to add percentages later. It seems there are outliers. Yes, we can see that this particular one of Setosa has a value above minus +2 principal component. And also they are outliers, but for now we won't deal with them. Biplot is not working. Let me give that question to my colleague Helen to help you. Halulu, take that question into Q&A so that Helen can help you. Because here, once I ask a question, things are going to disappear. It is difficult to separate Vescola and Virginia. Yes, Vescola and Virginia share some things in common, which we will find out later. Okay. Okay, so I'm going to close this out and then share the script. Okay. So in the next part, we want to find out the optimal number of principal component using a Scree plot. Okay. The optimal number of PCA or principal components using a Scree plot. So this function phys underscore I is found under factor extra. So if you've not installed factor extra, you won't be able to use this function. So we are going to run line 126 to line 127. Okay. So let's run and see what happens. So we create, let me zoom this in. So does everybody has the blue chart, which is like a bar graph? In the chart, can I see, do you have this, the same graph like me? Okay. Okay, thank you. Okay, I'm going to zoom in the chart and then stop sharing. Then share the chart. So this is what we call a Scree plot. It consists of, it is a plot of eigenvalues. You remember each principal component has a corresponding eigenvalue and dimensions. The dimensions are the principal components, 1, 2, 3, and 4. So we want to know how many of the dimensions should we use in the further analysis. Now, when you use the Scree plot method, where the Scree plot starts leveling off, those are the number of dimensions or principal component you choose. So for example, we can see that we will take principal component number 1, and you can see that at this point of principal component number 2, the plot is trying to level off. It is beginning to level off. So in this case, we are going to choose principal component number 1 and number 2 in further analysis. So when you use PCA in your analysis of your data in your project, you have to present this Scree plot, and you have to explain that because it has an elbow, the first elbow is at this point of 2. Now we decide that the number of principal components that are explaining a lot of variability are principal component 1 and 2 from this Scree plot. So that is it about the Scree plot. Any question in the chat about the Scree plot? Any question in the chat about the Scree plot? Okay, we find that if the you see the eigenvalues, they are saying there's a red line showing that we should be selecting principal components with eigenvalues above 1. So I've chosen 2 because if we take only one principal component, we will be explaining only 73% of the variability and left with a lot of variability unexplained. So that's why we also take principal component number 2. You will find that in practice, when you go to collect data, you find that you will need 4 principal components to actually get 70% or even 80% of the variability explained. So look at both the Scree plot and also look at the variability explained to make final decision on how many PCs you select for your further analysis. Okay? Okay, so we are going to click this. So where the Scree plot starts elbowing, that is where you end picking the number of dimensions. So we are going to pick 1 and 2 in further analysis. So let me share the screen, the script. Okay. So we said that we can use the Scree plot, or we can look also at the eigenvalues. So the next part is to print the eigenvalues, which is line 130 to 131. So let's run that. So if you look at the console, you are going to see the eigenvalue. You will see, first of all, DIME1, which is principal component 1. It has an eigenvalue of 2.9 and has a corresponding variance of 72.96, which is approximately 73%. Then DIME2, principal component number 2, it has an eigenvalue of 0.91 and variance of 22.85%. So in looking at these values also, it confirms what we've already seen in the plot, that we can use principal component 1 and 2 in further analysis. Okay. Okay, so now we want to see which variables are contributing to this variability explained in principal component number 1 and 2. So let's run line 134. And then from line 134, we are going to construct a plot of correlation. And that helps us. I'm going to zoom in. Before I zoom in, do you have the same chart like me? In the chat, can you tell me whether you have the same chart? Okay. Okay, excellent. Let's zoom in. And I'm going to stop sharing the script. Then I'll share the plot. So I'm making it a little bit wider. Okay. So this chart here is telling us under principal component number 1, which variable is contributing most? So you see that if you look at the scale, we have those that are dark brown, then lighter brown, let's say moderate brown, and then light brown. So the ones that are dark brown are contributing most to the principal component. So we see that under dime 1, which is principal component number 1, it is sepal length, petal length, and petal width. Sepal width is contributing, but a little. You can see it's light yellow. Then principal component number 2 is sepal width, which is contributing a lot. The rest are not contributing much to the variability explained. So we see that principal component 1 is a summary of the sepal length, petal length, and petal width. At the same time, we saw that these variables had positive correlations. So as principal component number 1 increases, even the sepal length increases, the petal length and petal width. Okay. So let's close out this chart and then go to the next part. So we've been talking about how to select the number of principal components to use in further analysis. And we've seen that we need principal component 1 and 2. So you can also use phys underscore cos squared to see the variables contributing to both principal components. So you can click that. So instead of getting circles, now we are getting the bar graphs, and it also shows you the contribution of each variable to each principal component. Okay. If we want to look at individual contribution using a graph, instead of axis equals 1 to 2, you put in axis is equals to 1. That is line 141. So if you run that and print A, it gives you, you can see that we have 3 variables contributing most to principal component number 1. And the same applies to B. Okay. So these graphs are just confirming what we've already seen in the eigenvalues themselves, in the plots. So that is just trying to confirm. So in the next plots, we want to look at the scatter plot and then interpret. We look at the contribution, the relationship between the variables and the principal component. And since in this case, we've chosen to use the correlation matrix. So still, I go back and remind R that PCA underscore results consists of Irish, consists of the principal components. So run line 151, and then the data frame. And then we go to draw our scatter plot. So for us to construct the scatter plot, we are using the GG function, and the data is PCA underscore data, and X is PCA1, Y is PCA2, the color is species. So let's run that. Okay. So still this is telling us that setosa, as we saw in the scatter plot, is mainly summarized by PCA2 and a little bit of PCA1, while PCA1 mostly summarizes vascular and virginica. So we want to see we want also to look at the variables that we have versus the PCA. So if we run, sorry, I didn't talk about, if we run line 160 to 163, we get this plot. So let me give you 1 minute. You run line 160 to 163, you get a plot which shows us the sepal width, sepal length, and the relationship with the principal components. So let me see in the chart. Do you have the same graph like I do? Okay. Thank you. Okay, somebody is saying a break, and that is a facilitator. Can you imagine? But anyway, let me give you the let me give you the break. He has felt for you that you need a break. So let's come back at 5 minutes past 4. Let's go for a break and come back at 5 minutes past 4 and explain the meaning of this graph which we've just constructed. Okay. See you then at 4:05. Okay, welcome back from the break. When we went to the break, I hope all of you are back. Okay. Can we start? Okay. Okay. We went to the break after constructing this chart, and I want to zoom in the chart and we talk about this chart. Let me first stop sharing. Then I share the chart. Okay. Okay. There we go. Okay, from the chart, is it visible? Is it visible to everybody? Is the chart visible? Okay, and I'm assuming you also have the same chart. Okay, so we can see that we see arrows here, one corresponding to sepal width, another on petal width, and they are all green. Then we have close to red petal width and red, which is sepal width. Now, when these arrows are close to each other, like you can see sepal length and petal width, they are close to each other. It means they are closely related, or they have a closer association. If we are talking in terms of correlation, they are highly correlated. So sepal length, petal width, and petal length are highly correlated because their arrows are close to each other. The angle between them is less than 90. Now, if we bring petal length green and sepal width, we see that it is almost 90 degrees. Actually, it is more than, no, it's 90 degrees. No, above, sorry. It's above 90 degrees. And when it is above 90 degrees, it shows that those two petal length and petal width are negatively correlated. The ones that are close to each other are positively correlated, whose angle is less than 90. They are strong and positively correlated. These ones are negatively correlated. So even the same applies to sepal width and sepal length. It is actually at 90 degrees if you draw here. That means these two are unrelated, sepal width and sepal length. Meanwhile, we also have petal width and sepal width. They seem to be unrelated also, or the angle is greater than 90, and that shows that they are negatively related. And when we interpret them in terms of the principal components, it's just confirming the results we got from the output that principal component number one, the 73% explained, is contributed by the sepal length, the petal width, and the petal length. It also shows that as this principal component number one increases to the positive side, even sepal length, petal width, and petal length are increasing. While as principal component number one increases, the sepal width is decreasing, meaning it has a negative correlation with principal component number one, which we saw in the results. Then when we come to principal component number two, we see that all these arrows are going far away from principal component number two, but sepal width is the one that is explaining most of the, contributing to the variability in principal component number 2. So if you wanted to run a regression, which we are not going to do today, we can do multivariate regression next time if we meet. You will run a regression of these two pieces versus these variables. And you'll also find that actually the variables shown here are the ones contributing to explaining the variability in the flower types. Okay. In the chart, if the angle is exactly 90, it means that they are unrelated. There's no relationship. If the angle is greater than 90, they are negatively related. If it's less than 90, they are positively related. Okay. Variability explained, that is the variance explained in the data set. The data set has noise, which is 100%. And when we construct the principal, we obtain the principal component 1 and 2, the variation or correlation within the data set is all summarized in the 2 principal components. Do all these plots mean the same? No. Somebody is saying it seems like we are talking about the same thing. Okay. So I'm going to stop sharing and then share the last bit. Okay. So the other thing we can do is construct a biplot. And what the biplot does, it also actually is a plot of principal component number 1 and number 2. And we can use different functions. We can use biplot in bracket PCA underscore results, that is line 165. So if we run that, we see a biplot. And this biplot has observations from the data set attached to them. It is also showing, so let me zoom in the biplot. Okay, it's already there. So let me stop sharing. So you can see that in the biplot, we have number 1 here is Setosa, and then we have the 2 Vascola and Virginia. Then we have the variables that were used. Okay, so we can see that Setosa here is mostly summarized by the sepal width. That is the one that can be used to summarize Setosa. Meanwhile, these ones here, Virginica and Vascola, petal width, petal length, and sepal width are the ones actually contributing to their having an overlap. You can see that they have an overlap. So tomorrow when they talk about clusters, we can see that we have 3 clusters. However, these 2 flower types have something similar, which is the petal length, petal width, and sepal length. Okay. So this is a biplot. And then you can also draw the same. So let's see. So this is another, you can use the GG biplot. So line 167, if you run it, you will get the same biplot. So this one, the GG, you can modify and put in color instead of black, you can draw different colors. So the same explanation. So let's see, we can also use the function under factor extra, which is physi underscore PCA underscore biplot. And we see what type of graph we get. That is line 171. And this shows you arrows. It shows you the petal length, sepal length, but still telling you the same explanation that sepal width is contributing to the variability in principal component number 2. And meanwhile, sepal length, petal length, and petal width are the ones responsible for principal component number 1. And as they increase, as also principal component increases, because you can see the arrows are pointing in an increasing direction. So we can also extract scores and loadings, which are part of the PCA underscore results. You remember that in the first part, I showed you that PCA underscore result consists of so many things, including the principal components, the eigenvalues. We can extract them and look at them, or even use them for plotting. Remember that principal component is not a confirmatory test. It is explanatory, meaning that you're just constructing graphs, looking at if there are any numerical values you can look at. That's what it does. You're just looking at the trend. So now it just leads you into another type of analysis. For example, here we can see that there are 3 groups. So in that case, you can go and do cluster analysis to confirm whether those groups are correct. So cluster analysis can be used to confirm whether those 3 groups are correct, whether the observations were correctly placed in the different flower types. So that's why you see we are looking at graphs, and we don't have p-values, etc., and values and numerical values. Okay, so now we are going to use those loadings in creating a customized biplot and see whether it makes sense. Not really fascinating. It is also another plot with setosa here and also vascular in the 2. I was trying to draw circles around them, but I didn't get much time. So you can go and work on this last part, which I was working on, to see whether you can draw circles around these plots. I think that's the end of principal component analysis. In case you have questions, we can have in the chat, you can put in your questions. And maybe if my colleagues have anything extra to add on, they can add on. So Helen, do you have anything to add on? And Thomas, do you have something to add on? Tomorrow we are doing cluster analysis. And somebody is saying confirmatory test. Let me see the question. After doing PCA analysis, now that you've observed that the data has 3 groups, we can go and do cluster analysis to confirm whether those groups exist. And then we can do discriminant analysis to qualify the groups. Or we can also use discriminant analysis in case we collect more data about those flowers to group them into the different groups. Okay. So in the discriminant analysis, you even have a p-value which helps you to know that this particular observation has been rightly placed in the group where it is. So tomorrow, my colleague will be talking about cluster analysis. I don't want to preempt what she's going to teach. Okay, next question. Does it mean that if you're having p-values, then that is confirmatory? Yes, because p-values test a hypothesis, and you're confirming that hypothesis with the probability that you compute. Does the training have a certificate? That question goes to the administration. They will answer that one. Can I have links to yesterday's slides? They are in the Google Drive. If you open the Google Drive, you will see day 3, day 4, day 1, and day 2. All those slides are there. You can access them and listen to the recordings. I believe the recordings have already been posted. Let me look at Q&A. The question is, I explain more about the Biplot graphics. How do these lines set? I believe they are talking about the lines in the Biplot. Difference between eigen and dimension. Dimensions are the principal component. Eigenvalues consist of the amount of variability corresponding to each dimension. Dr. Helen, can you please reshape yesterday's documents with me? Okay, Dr. Helen will answer that. Dr. Helen, Dennis has a question. Can you help them? Okay. Q&A, yes. Okay. Function fees underscore ig not found. Make sure you've installed Factor Extra to be able to run this. Okay, even the anonymous attendee, make sure you install Factor Extra and load it. After installing, make sure you load. All those who are installing packages, make sure you load, then they will work. Oh. Can you please send the link for the Arab book? This question I forwarded to my colleague, Dr. Thomas. Please send the link for the book you told them about yesterday. Okay. Thank you, Anonymous. You've solved your question. Yes, you can present the PCA in table format. You remember the eigenvalues? Those eigenvalues tell you about how much each PCA has summarized. Then we also had the variables corresponding to each PCA, so you can present that instead of a graph. Dr. Helen talked about the certificate. the certificate. Can you see? Okay. Discriminant analysis will be done next time, not now. In case we get an opportunity, next time we'll be talking about discriminant analysis and all other types of multivariate. It depends on the person organizing the training, what they want us to pass on. Once I standardize the data, when you say scale equals something, that means you're standardizing the data. Okay? So the program does not show you that it is actually picking one variable and standardizing, but once you tell at the beginning of PCA, you remember line 90, if you go to line 90, it has scale equals to 0 and center. So those two, we were looking at standardization. Will week 1 be repeated? I don't know. There is the anonymous attendee. First, go back and install all the packages that are highlighted in the script. Then load them. After that, this particular line is going to work. How about maneuver and simpler analysis next time? Remember that when my colleague, Dr. Helen, was teaching, she updated the visualization R. That's why we have to visualization updated R. Okay. You can ignore a visualization R and use visualization update R. Okay. So there was a question about explaining the biplot again. Okay, let me stop sharing here and see whether I can pick the biplot among the things that I were below here. Ooh, okay. Let me pick one with color. Okay. They are what? I'm trying to look for the biplot. Okay. Okay. So somebody said that we should rehearse or explain more about the biplot. We have this biplot here, and this is setosa. Then we have Virginica and Virginica and Vescola. We also have arrows, petal length, petal width, sepal length, and sepal width. We also see that it's a plot of PCA2 against PCA1. This information already is summarized in that data frame. You remember the data frame we formulated. It has all this information. Now, these are values, the data values, the raw data values that were presented in your data set. Okay, they are the ones that are being shown here, so that you can look for data value 42 and see whether it's an outlier, and 110, and also these ones here. Okay, so we say that if the arrows are close together with angles less than 90, then those variables are positively correlated. At the same time, we see that these arrows are increasing as principal component increases to the positive side. So they are the ones that contribute to PC1 and also positively related. So as PC1 is increasing, even petal length, petal width, and sepal length is also increasing. Meanwhile, as PC1 is increasing, sepal width is decreasing. You can see its arrow pointing the negative side and also downwards. But when it comes to PC2, it also shows that as PC2 is increasing, sepal length is still behaving the same way. Probably we can rotate them and make sure that PC1 is on this axis, Y, and PC2, and see how it happens here. But before we did the analysis, we saw that sepal length was actually positively correlated to PCA2. So that is it about. Then these two are overlapping. You can see we have 3 groups, but these two are overlapping because they share the petal length and petal width. It is contributing to their overlap. You can see petal width and petal length very closely related, contributing to the overlap of Virginica and Vascola flowers of Irish potato. Okay. Share the graphs you are explaining. Please, if you run the script, I'm using the same script. And if you run the script, you will see the same plots. Okay. Somebody is saying, he's saying the course is really good. Can we plan for more? They've heard. How can I locate my saved script? First of all, go to R and go to File, Save As, then save in a folder that you can remember. Then you can locate them. Or you go to File, Recent. It will help you get your saved scripts. I think I have answered all your questions. Most of the queries, Dr. Helen is saying that they're about packages. So it means that you didn't load the packages. So please load the packages and then If you've installed, load them. If you've not installed, install and then load. Okay. That question goes to my colleague, Thomas. Thomas, can you plan Python? Python actually is just like R. You just need to change. Yes, if you learn R, then you know Python. If you get the two scripts and put them together, you will see you change a few letters and you know Python. Okay. Okay, I think I'm going to stop here since we've exhausted most of these questions. And I'll stop sharing here. And let me hand over to my colleague, Dr. Thomas, to add more. Thank you very much. You've been excellent participants. Thank you.
Hi. To the training, we also can you please? Sorry, I'm still. I let my colleague first mute and then, okay, I think she has now muted. So yeah, thank you for this. Yeah, for future courses, I think we are going to continue to conduct more training together with the forum, but also if you feel you need some specialized training, you can contact us and you can organize, and we are willing to come. If your institution wants specific training, we will always be there. So like we've been saying or re-emphasizing since the first day, the main idea here is that you should be in position to identify the needs. Like you said, okay, for my research, I think these are the techniques that I want that I would like to use, or these are the techniques that will meet my objectives. So when you're doing analysis, always think about your research objectives. And that is why sometimes people misuse techniques, because they just run techniques because they see that somebody else has used to run the same technique. So it's important that you identify your objective very clearly and then look at your objective and try to relate to what we'll be talking about. If you require multivariate, then you go multivariate. If you require univariate, then you also go univariate. We are not able to cover everything within the week, and that's why there are many things that we left out. But we will continue to liaise with the forum so that more of the courses can be organized, and then people get at least increase the size of their toolbox so that you're able to use. So this is the message I have for you today. Thank you from my side. Tomorrow we can pick up from there. Maybe my colleague Ellen want to say a word? Otherwise, then we can. Yes, Ellen, can you say a few words?
Okay. Hi, everyone. It has been great moving with you from Monday up to where we are. From what the prof has presented today, I think most of the challenges within R, they're about like loading the different libraries required, because each time you run a command and then you come up with something that a particular function is not seen, then there are high chances that a necessary package that is required to run that function was not loaded. So most of the time, I would encourage you that before you run a script, make sure that all the necessary packages within the script that you're going to run are loaded. And then that will make it easy for you to see that you don't get most of the complaints that you're encountering. But also on the other side of the coin, each time you get errors, it shouldn't be really a big problem, or you shouldn't get worried. You can also get that error and paste it in Google, because in the beginning we said that R is an open source, implying that the problem that you're encountering, somebody else, millions of other people have got the same challenge. So in case you paste that particular problem in Google, then you're going to see some other people and see, how were they able to get the solutions? And then you can also do the same. It just needs some extra reading and then commitment and then practice, and you'll get there. But I'll just say that R is friendly, and like any other software programming language, all you just need to do is to practice, and then in case you get an error, you check, you see, how can I really solve that? But we'll catch up tomorrow when we are doing the cluster analysis for more information about multivariate. I'll be talking about different statistical techniques, but we're not going to cover them this time around. This particular week is just dedicated to multivariate analysis, and maybe in the future trainings, that's when we'll tackle other statistical techniques. I wish you the best, and then I'll catch you tomorrow. Bye-bye. Thanks. I think I will hand over to the forum. Is Dr. Runyararo on? Over to you.
Yeah, if Dr. Onyararo is not coming on, then I think we can end today.
Yeah.
Yeah.
Okay.
Thank you very much, everyone,
Mm.
and bye.